Okay, guys, we'll do the check your understanding on page 397. To introduce her class to binomial distributions, Mrs. Desai gives a 10-item multiple-choice quiz. The catch is students must simply guess an answer, A through E, for each question. Mrs. Desai uses her computer's random number generator to produce an answer key so that each possible answer has an equal chance to be chosen. Patty is one of the students in her class, so let X be the number of Patty's correct guesses. Okay, first we're going to show that X is a binomial random variable. Okay, I just jotted down a few of our information. So, binary, is there a success and a failure? Yes, the success is that the answer is correct, and failure is the answer is not correct. Is each answer independent of the other? Yes, okay. Each answer is independent because she used a random generator, random number generator to figure out the answers. Okay, is there a set number of trials? Yeah, there's 10 questions. And is the probability of a correct answer consistent? Yeah, the probability of a correct answer is 1 out of 5. If it's A through E, those are 5 options, so only one of them is going to be correct. So it doesn't change from question to question. So this is binomial. So we could say this is binomial. There's 10 trials, and the probability of success is 1/5. Do you get that? Mm-hmm. Okay. Next question says, probability that, let's find the probability, you can come down here, that X equals 3. And what this means is, what's the probability that Patty gets exactly 3 out of the 10 questions correct? Okay. Now, we can think of this in terms of a tree. Okay, so we have question 1, and there's 5 choices, A, B, C, D, and E. Right? Mm-hmm. This is question number 1. They all have a 1/5 probability of being correct. Then question 2, 1, 2, 3, 4, 5. I know I'm only going to do 2. Actually, I'm not even going to do them all. A, B, C, D, E. A, B, C, D, E, and so forth. And these all have the same probability of being correct. And they're independent, okay? Now I could go, oh, sorry, this is question number 2. I could do a tree for question number 3, or keep going with number 3, number 4, number 5, and through 10. But that's like too much work, okay? But I know 3 out of the 10 have to be correct. So I know as I go down my branches, okay, 3 of them have to be correct, which means 7 are incorrect, okay? Actually, I should have done correct and incorrect, whatever. You know what I mean, correct and incorrect. That makes more sense than this. Okay, so if I had done my tree of correct and not correct, and then correct and not correct, correct and not correct, so this is number 1, this is number 2. So this is correct, 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 okay? So I'm looking for the branches that have 3 correct answers and 7 incorrect. But there's going to be tons of branches. So this is where we've got to figure out a faster way to figure out how many branches have this combination of 3 correct and 7 incorrect, okay? So that's why we use a binomial. And it says, the formula is, we're going to do a combination of n choose k and times the probability of success to the number of successes and the probability of failure to the number of failures. Okay, well, that's this. This is the probability of success for the number of successes that I want. Okay, so this is the probability that X equals 3. I'm just going to write it down there. Okay, these are my failures, and of course 10 minus 3 is 7, so these are my number of failures. This is the part that's going to take some doing, okay? We can do a combination of this in a calculator. It's called, it's just combination of permutations. So if I do, I have 10 trials and I want 3 successes. So if I do 10 choose 3, on my calculator, if I do 10 choose 3, it's over here somewhere. There it is. If I do 10 choose 3, there's 120 branches, okay? So this would be replaced with 120 right here, okay? So there's 120 branches that have 3 successes and 7 failures, okay? But we're not going to go through all this. I am going to calculate this because I'm just curious. I just want to make sure. I want to show you that it works. Whoops. So there's my 3 successes and my 7 failures down my 120 branches. So the probability that she gets exactly 3 out of 10 is about 20%, okay? But we don't need to go through this every single time, okay? We are just simply going to use binomial PDF for an exact, PDF is an exact value, in our calculator, okay? So binomial PDF in your calculator is, are you with me? Mm-hmm. Second vars, there's your normal PDF and CDF. We only use normal CDF. If you scroll down, there's your binomials. So there's binomial PDF. We want the number, oh, that's already in there. We want the number of trials, the probability of success, and then the X. So we're going to do 10 trials, probability of success is 1/5, number of successes I'm concerned with is 3. So I have binomial PDF, 10 trials, probability of success is 1/5, and I'm concerned with 3, and if I hit equals, that is exactly what I calculated before. But that, here, show up a little bit. This little bit right here was much faster than having to do all of this, okay? And you're not expected to know how to do all this, but you are expected to know this formula, okay? Because you'll see this in a multiple choice question and things like that. I always tell people, if you have to do this in a free response question, I would write out this formula, and then run it as a binomial PDF on your calculator. You get the same answer, but it's showing them that you know number of successes, number of failures, and number of branches on the tree, okay? All right, the next question says, where am I? To get a passing score on the quiz, are you up here? To get a passing score on the quiz, a student must guess correctly at least 6 times. Would you be surprised if Patty earned a passing score? Compute an appropriate probability to support your answer. Okay, I want to cover this up. All right, so we have, that's all right. We've got 10 questions. At least 6 means what? How many answers? Correct. If we want at least 6 correct. What? Answer me. If I want at least 6 correct, okay, this one was exactly 3. So exactly 3 is easy, right? 3 out of 10. At least 6 would be greater or equal to 6. Good. So 6, 7, 8, 9, and 10. Okay. Now again, I could do all my branches to figure out how many 6 out of 10 correct, 7 out of 10 correct, 8 out of 10 correct, 9 and 10, and add them all up. But that's a lot of work. So again, I'm gonna do my binomial. Oops. PDF for 10 trials, probability of success, and 6 correct. Okay. Oop. Shoot. Okay. So I'm just gonna hop up here and grab this one and change it to a 6. Okay, so the probability that I get exactly 6 is point. That's not what I got before. Mm-hmm. Binomial PDF. Shoot, what am I doing wrong? Binomial PDF. Oh, I didn't change the 3. Darn it. There you go. 0.0055. Okay, so the probability of getting exactly 6 out of 10 is 0.055. And I just used the same binomial PDF that we used before. So I can do the same thing for getting 7 out of 10 correct, 8 out of 10, 9 out of 10, and 10 out of 10. Okay, so I can calculate the individuals and then add these all up, and that would be my probability. If I add these all up, I get.
Yeah, so she's not going to pass.
What?
She's not going to pass.
yeah, there's only a, what, 6% or a 0.6% chance of Patty passing. So I would be really surprised if she passed, okay? Now, again, what if I asked you, there was 100 questions on the test, and I said you had to get at least 60 correct. You're not going to do 60, 61, 62, 63, all the way through 100. That would take forever, okay? So what we're going to do is we're going to use a binomial, oops.
Wait, if it was 60 out of 100, can you just boil it down?
No,
Six.
no, you
Oh,
have to
really?
do each individual one because there's a different probability of getting 60 correct, 61, 62. We're going to do a cumulative. C means cumulative, okay? Now, just like normal CDF, okay, because normal is always cumulative, it's always the area to the left, okay? So these are going to be the cumulative probabilities to the left, okay? Well, all of these individual probabilities, if I add them all up, because, you know, I add up these and I add up all these, they should equal 1 because they're the only options that are available to be the outcome. So in order to get this, I'm going to binomial CDF these and subtract it from 1, and I'll get that, okay? So this would be like the probability that x is greater than or equal to 6. Well, for CDF, I can't, I have to go to the area to the left, so I'm going to do 1 minus the probability that x is less than or equal to 5. And these are basically the same thing. So if I take 1, which is everything, subtract 0 through 5, I'll be left with 6 through 10. So 1 minus binomial CDF, I've got 10 trials, 1/5 is my probability of success, and 5. Now, remember, this is cumulative, so this is going to add up. Probability of getting 0, 1, 2, 3, 4, and 5 correct. It's saving me the time, okay? I don't have to do it. I'm going to go down. Binomial CDF. So I've got, can you see my calculator?
Mm-hmm.
5th and 5. So then I'm going to do 1 minus that. And I get 0.006369 pretty close, right?
Mm-hmm.
Still a 0.6% chance of Patty passing. Okay, so again, if you're only asked 6 out of 10, you could certainly scroll up a little bit for. You can certainly do each individual and add them up. I would not mark that wrong. It's beautiful. But if I gave you a 100 question quiz and said, what's the probability you get at least 60 correct, you're not going to do 60 through 100. That's too much. You're going to come down here and do your binomial CDF, okay? But you'll notice you get the exact same answer, okay? All right, that's it for that one. See you next time.